Under this chapter 2, we will be looking at 3 different units: 2.1 Bohr atomic model, 2.2 quantum mechanic model, and 2.3 electronic configuration. Each of these subtopics will be taking you an. So as you can see in the slides, we have 4 objectives under 2.1, such as describing Bohr's atomic model, describing the formation of line spectrum, writing the limitation of Bohr atomic structure, and also the nature of electrons. We look at a bit of history, how they came up with this Bohr atomic model. As the history goes, the model started with Dalton. You have heard about Dalton in the earlier studies, and later it moved on to Thomson. Thomson said we have positive and negative charges, and further to Rutherford, and the most current one is Schrödinger. Bohr is between Rutherford and Schrödinger. So we are studying about more detail about Bohr, because Schrödinger, it goes under wave, right? So as you can see in your slides, we have summarized the history. Bohr's atomic model, it came from a Dutch physicist by the name of Niels Bohr. According to his theory, the first postulate, electrons have energy, and this energy are quantized. Quantized means they have certain amount of energy, and they go around in the orbit. Certain orbit, you have certain amount of energy. If they are nearer to nucleus, they have lower energy. If they are nearer to nucleus, the energy they have is the lowest. When they move further from the nucleus, the energy will increase. When they have high energy, means they are easier, the electrons are easier to escape from the nucleus. When the electron escapes from the nucleus, it becomes positively charged, ion. In this slide, you will see 4 Bohr's postulate. The first postulate says the electron moves in a circular orbit. I mean, it goes round the nucleus. Nucleus is the center. And if the electrons want to move to a higher level, they need to absorb energy. If the electrons want to move to nearer to nucleus, they have to emit energy. Emit energy means throw out the energy. So the symbol for energy will be negative. When it throws out the energy, your symbol delta E will be negative. That means energy is given off. Energy is given off, can be form of energy, can be in form of light. So when the electrons are just going around the orbit, they do not absorb or release any energy. It only happens when they move from higher level to lower level, or from lower level to higher level. As you can see the diagram, the energy level, you see 3x. If they are further from the nucleus, level is higher. So this diagram explains about Bohr's postulate. So orbit, the way that it takes, the pathway, that is called as orbit. So sometimes we use the word orbit, we use energy level. So to calculate, the second postulate says that every level they have their own energy. So when they are in the first level, look at the energy. So how do you know this energy level? We have a formula to calculate. So each level they must have that much of energy. For if they are lowest, so it's negative 2.179, lowest energy level. And if they are the highest energy level, you have negative 0.316. So they are all fixed. So emitted or absorbed depends on where they transit. You see now it's going to lower level, it will be emitting light. So all these structures are just explaining, yeah, the concept of energy absorbed and energy emitted. So when energy is emitted, it not necessarily must be in the form of energy. It could be in the form of electric wave. So this is the formula. Okay, remember, formulas are very important for this topic. The formula given here is to calculate the energy level. Energy level here means when the electron going around the nucleus at the certain orbit. It's not yet jumping, not going to higher level, it's not going to lower level. It's just going around the nucleus, they must have energy. So this is the calculation. You can see that is RH. RH is referring to a constant, Rydberg constant is given, these values are given, and is which is the orbit is staying. The electron is staying. So if the electron is staying in the first level, your n will be 1. If the electron is staying in third level, your n is 3. Right. When can the energy become 0? When the energy becomes 0 when your n is infinity. Infinity here means the electron got no attraction force with the nucleus. As shown in the slide, the energy, ground state, they have the strongest attraction towards the nucleus. So when they go further and further, the energy become less and less, and finally they are free. When they are free and is infinity, the electron the atom for good. These are the explanation. Now we are going on. So we know that Bohr, it has 4 postulates, 4 postulates to support Bohr's atomic model. Now we are going on to line spectrum. Okay, what is line spectrum? A spectrum, it contains discrete line separated by blank area, and each line corresponds to specific wavelength. This is a spectrum. A spectrum. From the spectrum, you can see each line has, these are called as lines. Each lines here, they have specific frequency, specific wavelength. So if they are here, they must have certain frequency, certain wavelength. Then only they can fall here. How do you get the lines? The lines you get due to the movement of electron from higher level to lower level. Higher level to lower level, you know that electrons will emit light. So the light is already transformed into a line spectrum. So for example, all the electrons from different level, they end up in n is equals to 1. So when it's n equals to 1, light will be radiated. So when the light is radiated, they fall under ultraviolet. So all the electrons from different level, they end up at n is equals to 1. Then you call it as Lyman series. Lyman series. The light that is emitted is called as ultraviolet. When they fall into n equals to 2, all the electrons, you must remember that in an atom we have a lot of electrons. So if the electron decided to go to n equals to 2, it becomes visible light, and we call that as Balmer series. So you must know, when visible means it's Balmer series. If it's ultraviolet, it's Lyman series. If it is Pascal series, your n must be 3. If it's n is equals to 4, infrared. After that, it's all infrared. So formation of line from n initial to final, energy is absorbed, and when the electron from higher level to lower level, energy is released. This diagram on the right, energy is released. Why is it released? Higher level to lower level. So initially the electron was staying here, then it dropped down to final. Absorb. So which one will give you a line spectrum? The one that energy emit will give you line spectrum. If energy absorb, you don't get any line spectrum. Yeah, it will be dark. These slides explain how is the line spectrum formed. How is it formed? So line spectrum can only be obtained when the electron from higher level they drop down to a lower level. Upward. Yeah, they're moving upward. So it's from lower level to higher level. So all moving up, you don't get a line spectrum yet. From low level, how they move to higher level? Absorb energy. So when they go to higher level, they become unstable. So when they become unstable, they drop down. When they drop down, then only you get your line spectrum. So when they fall back, so line spectrum, each ball here represent one photon, the frequency. So Bohr has 4 postulates. First postulate says electron moves in a circular orbit. Second, it says that each level the electrons are quantized. That means if they stay in second level, they must have certain energy to be in second level. If they want to move to third level, they have to absorb energy. Maybe when they go to third level, they are not stable. They want to drop back. When they want to drop back, they will emit energy. Yeah? So when in the particular level, they do not absorb, they do not release, but they have their own energy. Yeah? So these are the 4 postulates of Bohr. And the important equation for calculation, okay, you can see here delta E is equal to H. V here is frequency. If energy is given, you can convert to frequency by using this formula, or frequency is given, you can convert it into energy. So we use the first formula. The second formula, you can convert energy into wavelength. This is symbol for wavelength. And the third one, frequency, you can convert it into wavelength. Frequency and wavelength. This one is energy and wavelength. C is a constant speed of light. H is Planck's constant, is given. So if given here means you don't have to know the value. In the exam, they will give you the pamphlet here, the booklet where you have all this energy. Okay, the fourth equation, remember, this equation is for what? To calculate the energy at the orbit. I told you when they're in the orbit, they have energy. So this formula you use. RH is Rydberg constant. N is the position of the electron at the orbit. So RH is in joule, energy. Yeah. And the fifth equation is for calculation when the electron move from one level to another level. So your answer here could be positive, could be negative. Yeah? RH value is still the same. E can be negative, E can be positive. And the final one, yeah, final one, what's the difference between the top one and the bottom one? The top one, your answer will be in joule. So that's why your RH will be in joule. If you are using the last formula, you are not calculating energy, but you are calculating wavelength. So when you want to calculate the wavelength, your RH value cannot be in joule. So it has to be in meter, per meter. So that's why our RH value, we are using a different value. So we have 2 RH value, you have to be careful which RH value you need to use. Yeah. And here you see it as I and F, initial and final. They can be in 4th level, they drop to 3rd level. So 4 becomes 3. The last one, you don't use I and F because your wavelength will be always positive. So therefore, you need to take a bigger value for N2. N2 will be a bigger value, N1 will be a smaller value. So your wavelength is always a positive value. Then they explain using Bohr. And another weakness is electron got two character, dual nature, two character. So to explain that, we have de Broglie and Heisenberg uncertainty principle. These two principles came out because atomic Bohr cannot explain extra line. So for that, we have equation. The equation is telling electron is not a particle, it is a wave. So to calculate wave, we have a equation there. Heisenberg uncertainty principle, we also have another equation. But here you don't have to worry so much because we won't be using all these equation for calculation. Just now I showed you a list of formulas. That formulas are very important. This topic, basically you must know how to use the formulas. These two formulas you can just ignore because Bohr's theory got weaknesses. So to overcome the weaknesses, we have two theory here. One is de Broglie postulate and one is Heisenberg uncertainty. Yeah. So de Broglie says that electron has wave property, and Heisenberg uncertainty principle say that you cannot determine the position of the particle. So you want to like atomic Bohr said, n is 1, n is 2, n is 3. But for Heisenberg uncertainty principle, you cannot determine the position. That's why they said position is uncertainty here. Position of the particle. You want to know the correct one, the position, you have to use the formula.